So let's have a look at the other special type of series we're interested in, and that's geometric series. And the definition is pretty much the same, but instead of using the word adding, we're using the word multiplying. So we multiply by the same amount each time, and we call that amount we're multiplying by the ratio, or the common ratio, symbolised R. So if I wanted to work out the ratio, any term, but now I would divide it by, because it's a ratio. So what's the ratio of term 2 over the first term? Or term 3 over the second term, and so on. So again, I could get any term and divide it by the term before. This one we've got to be careful with though, because I could grab any two terms, but if they're an even number of terms apart, then there's going to be two possibilities. Because if it's a negative number, well, if you do it an even number of times, negative times negative, of course, is a positive. But positive times a positive is a positive as well. So is it negative, is it positive? If we get that situation, then unless they give us more information, then we would say, well, both are possibilities. The recursive formula, so playing around with that one, we'd get the term n is simply equal to the ratio times the term before it. Let's create the general formula. So first term's A, term 2 is R, term 3, well, R squared, but not for a pirate, it would be R. And you can keep going, and it becomes lots of fun. You get the fifth term, and then it's R. So we get AR to the power of n minus 1. Right? This one would be an exponential function. Again, if you look at the general term there, you can see, oh yes, look, the pronumeral is in the power. That's the bit we're substituting in. We should end up with an exponential curve, but it wouldn't be a curve, it would be discrete points that you would plot, and you would end up with an exponential graph. 2, 8, 32. Find R. Well, I could just look at it and go, well, A is 2, R is 4. Be careful though. If they've told you it's a geometric one, I suppose this question actually told me that, I can't assume it is. So I would need to check as well and go, well, hang on, yes, 8 divided by 2, that is 4. 32 divided by 8, yeah, that is 4 as well. So we do have a pattern. So just be careful with that one. So AR to the n minus 1, subbing in, well, mere mathematicians would leave the answer like that. But us super mathematicians, that 4, of course, we can change to 2 squared. So we could rewrite this whole pattern to be 2 to the power of 2n minus 1. Here's one of the ones I was talking about. We've been given the second term. We've been given the fourth term. So they're an even distance apart. What's the general term? Well, AR is 7. AR cubed is 49. Remember, this is one of those situations. They're still simultaneous equations, but I'm not going to add or subtract to eliminate. I'm going to divide to eliminate, and we get R squared is 7. So R is plus or minus, and unless you give me more information, I don't know which one it is. So therefore, the first term, again, it could be plus or minus root 7. Because I don't know. I know the second term's 7, but I don't know if that ratio was positive or negative. So my general term, well, if it's positive, I'd have root 7 times root 7 to the power of n minus 1. And so tidying that up, I'd get root 7 to the power of n. But if the first term was negative, I'd get negative root 7 to the power of n. We normally don't leave it as negative root 7 to the power of n. We normally always pull out the negative and make that to the power of n, because that's basically making the pattern alternate, that negative 1 to the power of n. When n's odd, you get a negative number. When n's even. So we usually pull out the negative 1. What will be the first term of this one? 1, 4, 16 to be bigger than 500. So A is 1, R is 4. So we get 1 times 4 to the n minus 1. That's just going to be 4 to the power of n minus 1. So when is that greater than 500? Exponential, yes, you could just guess and check. It's a valid way of doing it. But let's use logs. Remember, how do you log? You just simply write the word log. So we now have the word log there, which allows me to bring n minus 1 to the front, divide by log 4, And again, I get a continuous answer of 5.48, but we're looking at a discrete situation. I want the first one bigger than that, so it would be the sixth term, which is 1,024. Be careful when you're doing this, because remember, log of a number smaller than 1 is a negative number. So it doesn't look negative. If you see log of a half, it doesn't look negative, but it's a negative number. So if you were going to divide by log of a half, technically you've changed the sign. And of course, if you change the sign, you change the sign. You'd have to get that inequality sign the other way around. Now, a word on arithmetic and geometric means. These become quite interesting in some of our extension proofs that we end up doing later on, or extension 2 proofs. You've already seen these, you just didn't realise it. See, we use the word mean, and it's sort of like a throwaway word when we're talking about the average. But in reality there's different types of means. These are just 2 of them. There are other ones as well. So what you think of as mean, average, is actually the arithmetic mean. So when you add up all the terms and divide by the number of terms that you have. Geometric then, instead of adding, because it's geometric, we multiply all the terms. And then we find the nth root. Now, technically, plus or minus, because again, you've got that odd-even situation. But you'll find most places, geometric mean is just quoted to be positive. Certainly in the inequation ones that we look at, the proofs I'm thinking of, when we get to extension 2, but that's because, of course, all the terms in those sort of proofs are positive numbers usually, so it doesn't matter. But, as I say, theoretically, geometric mean, plus or minus. Why is it useful? Well, if you've got 2 numbers, say 4 and 25, and we want to create a number pattern, well, if I want to turn it into an arithmetic one, then the number that goes in the middle must be the arithmetic mean, the average of the 2 numbers. So 29 on 2, we could slot in the middle, and we end up with an arithmetic one. If I wanted a geometric one, I'll find the geometric mean. And again, there's that plus or minus, because I don't know, would that ratio be positive or would it be negative? But in this case, the ratio would be, well, the number, not the ratio, the number would be plus or minus 10. What about if there's more? I've got 2 numbers, but I want to create, I'm going to say, well, the first one's 2 and the fourth one's 128. I want to find x and y if they form a GP. I could say, so it's geometric, that x is the square root of 2y, because it would be the geometric mean of 2 and y. And y would be the square root of 128x, because it would be the geometric mean of 128 and x. So we've now created some simultaneous equations here. Y squared, therefore, is 128x. So because I'm squaring there, I don't have to worry about the plus or minus. So that's going to be 128 times root 2y. Again, I don't have to worry about the plus or minus because it's y squared. We're not dealing with imaginary numbers here. So y to the power of 4 would be that. Factorise, I get 2 possibilities. The first one is the trivial solution. If I made y equal to 0, I think I'd end up with a very trivial solution. Or y is equal to 32. Now, that trivial solution in the geometric one, because it's a fact that 0 can never be a number in a geometric series. Because at some point, if you want to work out the number before it or after it, you divide by it. Well, you can't divide by 0. So it would be impossible for 0 part of the pattern. So we know that 32 must be y, which means x is 8. Enjoy.